Now what is time scaling? Time scaling is an operation which is done on the independent variable. Now the independent variable is t. So if I consider x of t, the operation is on the independent variable t. So now I have a given signal x of t and I need to scale t. That means I have y of t equals x into a into t. I'm multiplying t by a factor a. Now what happens to y of t? Now if the value of a is greater than 1, if a is greater than 1, then what happens? The given signal x of t gets compressed by a factor a. So there is compression. It gets compressed. So if the value of a is greater than 1, then the given signal x of t gets compressed by a factor a, and that would be equal to y of t. Now on the other hand, if y of t is equal to x into a into t, where a is less than 1. So if the value of a is less than 1, then what happens? The given signal gets expanded. So there is an expansion by a factor a. So this is, it gets compressed or compression by a factor a, and this is expansion again by a factor a. Now let's take a few examples and see how there is compression or how there is expansion taking place. Now before I proceed, do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and also to get the information about the books which are published for children. The information has been given in the comment section or has been given in the description. So do join the Telegram group to get all the details about the books published. So let's move further. So here I have a given signal x of t, which varies from -1 to +1, where the amplitude is equal to 1. And if I need to find x of 2t, that means y of t equals x of 2t, what happens? The signal gets compressed by a factor 2. So what is y of 0? Y of 0 is nothing but, so how do I draw the compressed signal? So when t is equal to 0, for y of t, when t is equal to 0, I get the value of x of t at t equal to 0 as 1. So I have 1 here, right? When t is equal to half, y of half is equal to x of 2 into 1 by 2, which is equal to x of 1. So at x of 1, I have the amplitude 1, and this amplitude will be at y equal to half. All right. Now for t equal to 1, what happens? Y of 1 will be equal to x of 2. Now x of 2 is nothing but the value of x of t at t equal to 2, which is 0. So therefore the signal drops down to 0 at t equal to half. Now the same thing happens here. So for t equal to minus half, y of minus half is nothing but the value of x at t equal to -1, which is 1, and then it comes back to 0. So what has happened? The signal has actually got compressed by a factor 2, right? So there is compression by a factor 2. So we can also state that within the given interval -1 to +1, just for our understanding, from -1 to +1, I have this given signal x of t. But now what happens? The same signal y of t will now lie between -half to +half, and the time duration is exactly equal to half of the time duration of x of t. So here the time duration of the signal is -1 to +1. So the time duration is 2 here, and here the time duration is 1. So therefore the given signal has been compressed by a factor 2. Now what happens if is less than half? So if I consider x of 1 by 2t, which is equal to y of t, so then what happens? The signal gets expanded by factor 2. Now let's try to do it directly because it's very easy. So I have 0, 1, 2, -1, -2. Now put t equal to 0. So if I put t equal to 0, I get x of 0 equals y of 0. So x of 0 is 1, y of 0 also will be 1. Put t equal to 1. T equal to 1, x of half is 1. Here y of 1 will also be 1, isn't it? So y of 1 will be equal to x of half when t is equal to 1, right? So y of 1 will be equal to x of half. What is x of half? X of half is 1 here. Similarly, when t is equal to 2, when t is equal to 2, y of 2 is equal to x of 1. So y of 2 will be equal to x of 1. What is x of 1? What is the value of x of t at t equal to 1? It is 1. So therefore it will be 1 here. And then it drops down to 0. The same thing for the other side. So for t equal to minus 1, I get x of minus half, right? So y of minus 1 will be equal to x of minus half. At t equal to minus half, the value is 1. So it is 1. And then for t equal to minus 2. So y of minus 2 is nothing but equal to x of minus 1, right? Minus 2 divided by 2 will give me x of minus 1. So at minus 1, the value of x of t is 1. So this will be 1. And then the signal becomes 0. So now what has happened here? The signal has got expanded. So there is expansion by a factor. So we have to remember this. So here I've considered continuous signals. So now let us consider discrete signals and let us see what happens when there is compression by a factor 2. So here we have a discrete signal x of n, which has been given. The value of x of 0 equals 2, x of 1 equals 1, x of 2 equals 2, and so on. And we need to find y of n equals x of 2n. So this is y of n equals x of 2n. So let's put n equal to 0. So if I put n equal to 0, y of 0 equals x of 0. That means y of 0 will be equal to x of 0. X of 0, you have an impulse of amplitude 2. So y of 0 will be equal to x of 0. Next, if I put n equal to 1, I get y of 1 equals x of 2. So y of 1 will be x of 2. What is x of 2? It is 2. If I put n equal to 2, y of 2 will be equal to x of 4. So x of 4 is 2. So you have 2 here at n equal to 2 for y of n. Now if I put n equal to minus 1, so y of minus 1 will be x of minus 2. What is x of minus 2? It is 2. And similarly, what is x of minus 2? When n equals minus 2, I get x of minus 4. So y of minus 2 will be x of minus 4. So this is again 2 here. So what happens when the value of a is greater than 1? I find that I lose out on the impulses. Okay, so all these values, that is x of 1, x of 3, x of minus 1, x of minus 3, are lost. So therefore I get y of n such that I have lost these 4 impulses. So here in this video segment we have dealt with time scaling, and in the next video segment we shall deal with time shifting, and then we shall also see the precedence rule when we have to apply both time scaling and time shifting together. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.